This video segment continues an historical account of Earth's climate. It covers the period from 1 million years ago to the present. An understanding of this history is critical for distinguishing between natural and human causes of the changes in climate that we have observed over the last few decades. The key points of the segment are: number 1, ice cores provide details about Earth's recent climate. 2, Earth has experienced multiple ice ages over the last million years. 3, interglacial periods have relatively high levels of greenhouse gases. And 4, all proxy measures show that global average temperature today is as warm as it has ever been in over 500 years. Ice cores from Greenland and Antarctica offer great detail about climate and Earth's atmospheres over the last million years or so. The next time you are in a bar, examine the ice cubes in your glass. If you are in an elegant establishment, the ice cubes will look clear because they are made in special machines that exclude dissolved gases from the water during freezing. By contrast, if you go to the bars that I frequent, the ice cubes are riddled with gas bubbles. So it is from ice from glaciers. As snow accumulates on top of a glacier, the weight of the upper layers compacts porous snow of the previous layers into ice, trapping the air bubbles within the ice. These little bubbles are time capsules, samples of the atmosphere that were taken when the ice was formed. Analysis of these air bubbles provides a direct assessment of how the composition of Earth's atmosphere has changed over the history of the glacier. Drilling and analyzing ice cores is difficult. The most promising drill sites are located in the coldest and most remote places on Earth. Drilling a deep ice core involves many hundreds of cycles of lowering a cylindrical drill bit assembly, cutting another 3 meters in depth, raising the assembly to the surface, emptying the drill core barrel, preparing the drill bit assembly for another round. In a clean room maintained below freezing, discs less than 1 millimeter thick are sliced off cores. Every disc is divided among various research groups, each specializing in a particular analysis. Dating a disk from an ice core entails keeping track of the number of annual cycles from the surface of the ice pack. Annual cycles are determined from seasonal variations in either the isotopic composition of the ice or the concentrations of contaminants in the ice. Usually, several of these parameters are measured for independent verification of annual cycles. Still, counting the years in ice cores presents a challenge, particularly as ice becomes compressed with depth or distorted from sideward flows. For example, the deepest sections of ice cores in Antarctica are so compressed that on average each year is represented by a disk less than 2 millimeters thick. At Dome C, located on the high Antarctic plateau, a European consortium has drilled an ice core extending to a depth of 3,270 meters. The deepest sections are 890,000 years old. Analysis of sections as old as 650,000 years are complete for greenhouse gases and the delta D, a proxy measure for temperature. Temperature records at Dome C show that Earth's climate during the last million years has been punctuated with cycles of glaciation comprised of relatively long colder periods interrupted by short warmer periods. Each of 9 interglacial periods correlates with higher concentrations of the greenhouse gases, methane, carbon dioxide, and nitrous oxide. Current levels of these gases, however, greatly exceed any time during the past 650,000 years.